So, good good day, everyone. So, I'm May and I'm Sarita, and the topic is all about binary codes. So, first thing first, let us know what is code. So, the term code can refer to any system of symbolic representation or a set of rules used to convey information or instructions. So, codes can be observed in different fields, such as in language itself can be seen as a form of code. Words and grammar form are structured system of symbols that convey meaning and enable communication between individuals. Next is also we can find codes in legal terms such as a set of rules and regulations that define and govern behavior within a society, typically written in form of laws, statutes, and legal precedents. Next is cryptographic codes. It is used for mathematical algorithms and techniques to secure and protect information. It also helps ensure confidentiality, integrity, and authenticity of information. Next is generic code. It is a set of rules that determines how DNA sequences are translated into proteins within living organisms. So if you want to know your DNA for basis of genetic information inheritance, there's also a code for that. Moral and ethical codes, it is a framework of principles and values that guide individuals and collective behavior, such as your how you define right and wrongs, the standards of conduct, and professional ethics. Lastly is the cultural codes. It is a shared system of meanings, symbols, and norms within a particular society or a group, and encompassing aspects such as the language, rituals, traditions, costumes, and artistic expression. So in summary, code can be observed in a diverse domains encompassing the language, the law, the cryptography, the genetics, morality, and culture, and etc. and more. So it also represents a structured system of symbols or rules that convey information, instructions, or guidelines for enabling communication. Next is the binary code. So binary code is a fundamental component of coding theory that represents data using a two-symbol system, typically 0 and 1. Each symbol, also known as a bit or binary digit, represents a logical value, which is 0 represents off or false, 1 represents on or true. Extensively used in digital communication, computing, and information systems. Under binary code is the binary arithmetic. In binary arithmetic, it is a process of performing a mathematical operations using binary numbers, which are numbers represented in the base 2 system, since it is by. So the word by means 2. So there are two digits, it equals to 0 and 1. Binary arithmetic used to express all numerical values, just as decimal digits 0 to 9 are used in base and arithmetic. So the first fundamental operation is the addition. It is also similar. It has a similar process in just like decimal addition. But then there's a rules to follow, which is 0 plus 0 is equals to 0, 0 plus 1 is equals to 1, 1 plus 0 is equals to 1, and 1 plus 1 is equals to 0 with a carry of 1. So to add binary numbers, start from the right digit and proceed to the left. If the sum of two bits or digits, binary digits, is 2 or greater than that, a carry occurs, which is added to the next column on the left. So example for that is letter A 100110 plus 110101. So to add that, we're going to use the rules of the binary addition. So 0 plus 1 is equals to 1. 1 plus 0 is equals to 1. 1 plus 1 is equals to 0. And we carry and we add 1. Yes. So we carry 1 to the next column on the left. So 0 becomes 1. So 1 plus 0 is equals to 1. And 0 plus 1 is equals to 1. And 0 plus 0, 1 plus 1 is equals to 0. And we carry out the 1 to the next column. And since there's none of that, so we bring down 1. So in each column of a binary number has a twice the weight of the previous column. So binary numbers are base 2. So as you can see here, for example, in binary, the column weights are from right to left. So in every column, there's a value of that binary number. So first column is 1, next column is 2, next is 4, 8, 16, 32, and 64, and so on. So 32 plus 4 plus 2 in this example, so 32 plus 4 plus 2 is equal to 38. So next is, so plus 1 plus 1. So under that is 32, 16, 4 and 1. So it equals to 51. So 38 plus 53 is equals to 91. If you get using decimal, convert into decimal numbers. Next is letter B. 101101 plus 111101 is equals to 11010110. So 1 plus 1, 0, carry 1 over. So the next column, so it becomes 1. So 1 plus 0 is equals to 1. So 1 plus 1, it becomes 0, carry over to 1. So 1 plus 1 plus 1, it means 3. So we need to carry 1 over here. In binary, 1 plus 1 plus 1 is equals to 3. So we carry 1 over here to the next column. So 0 becomes 1. So 1 plus 1 is equals to 0. And we carry over 1 to the next column. So it becomes 1. So 1, 1. So here's the decimal value of this. Next is subtraction. In subtraction, it has a similar process as to decimal subtractions. So the rules here in subtraction is 0 minus 0 is equals to 0, 0 minus 1 is equals to 1, with a borrow of 1, 1, and let's just say 1 minus 0 is equals to 1, then 1 minus 1 is equals to 0. When subtracting, start from the right, just like the in addition, proceed to the left. If a borrowed value is required, it is taken from the next column on the left. For example, so A 1001011 minus 011011. So as the rules apply, 1 minus 1 is equals to 0, 1 minus 1 is equals to 0. So 0 minus 0 is equals to 0, 1 minus 0 is on. So in here, so 0 minus 1 is equals to 1, since we need to borrow 1 from the next column on the left, so it becomes 0 becomes 1. Oh no. So the 2, so 2, since binary is it has a base of 2, so 2 minus 1 is equals to 1. And this one comes to 1, since we borrow 1 from here on the left side, so it becomes 2 less. And then we borrow here from the next one. So the binary, so the decimal value of 1001011 is 75, and then the 11011 is 27. So that's 75 less 27 becomes 48. So the answer is C. Letter B is 1000110 minus 1000100. So the answer is 0 plus 0 is equal to 0, 1 minus 1 is equal to 1, 1 minus 1 is equal to 0, 0, 0, 0. So here we borrow 1 from the next column, so it becomes 0. So 0 becomes 2. 2 minus 1 is equal to 1. So the decimal value of 1000110 is 70 less 36, the value of this one. So it becomes 70 minus 36 is equals to 34. Next is multiplication. In multiplication, binary multiplication follows the same principles as to the decimal multiplications. So the basic rule for binary multiplications is 0, it's just 0 times 0 is equal to 0, 0 times 1 is equal to 0, 1 times 0 is equal to 0, 1 times 1 is equal to 1. So multiply each digit of one number by each digit of the other. Starts from right to left, the result product are then summed to obtain the final product. So, for example, is letter A 1001 times 111 is equal to 1001. So we multiply it from just like as decimal multiplication. So 1 times 1 is equal to 1, 1 times 0 is equal to 0, so 1 times 0 is equal to 0, and 1 times 1 is equal to 1. So this as it is. At this notice, it is as the same number, so just need to copy this one, and then after we get the product of the three digits, so we add that up. So 1, bring down 1, so 0 plus 1 is equal to 1. 1 is equal to 1, so 1 is equal to 0, 1 plus 0 is equal to 1. Decimal value of 11111 is decimal number 16. So letter B is 10011 times 1001. So just like example letter A, we just need to multiply it in the upper part. So 1, so the value of this is just need to find 1, add that up to get the final product. So the final product is decimal of 107. Next is the binary division. So division, it has a similar process in decimal division. The basic rules as follows. Involves dividing the dividend by the divisor and obtaining a quotient and remainder. The process continues until the dividend is fully divided. So example letter A is 10101 divided by 1 1 is equals to 111. So how to get that? We need to divide it. But this is so the rule is so this so letter A so 0 so 1 0 can be divided by 1 11 101 is 0. 101 divided by 1 is equals to 1. Then when we multiply it, it becomes 1 So over. So we need to subtract it. So 1 minus 1 is equal to 0. And we'll borrow 1 from here to the left side. It becomes 0 becomes 2. 2 minus 1 is equal to 1. And bring down 0. So 100 and 100 divided by 1 is equal to 1. So the quotient is 1. Multiply it by 1, it becomes 11. So over, subtract it again, so borrow 1 from here, then add 0 becomes 2, but we need to borrow another 1 again, so the 0 on the right side will become 2. So 2 minus 1 is equal to 1, and 1 minus 2, 0. So the 1 becomes 0, and bring down 1. So 1 divided by 1 is equal to 1, so 11. So there's no remainder here. The decimal of 1 is 7. Next is letter B, 10100 equals to 10 or 1010. So here, just like that, example letter A, we multiply since the quotient, since the divisor is less than the dividend. Since the divisor is in the dividend, so we put 0 on the quotient, so 0, 0, 0. 1 minus 1 minus 0 is equal to 0. 0 minus 0 is equal to 0, and 1 minus 0 is equal to 1. So then go 0, since you can divide it by 1, so bring down the 0, so 1 0 1 0 is 0 0, so 1 1 over subtract it, it becomes 1 1 0. So next we bring down the 0, is equals to 1 0 0 0. So we divide it, so 1 1 0. So the remainder for the example letter B is 1 0, which is the decimal of 6. So the answer here is 1 0. So in the column it is the decimal of 1 0 is equals to 2. So in binary arithmetic, it is a fundamental to defeat systems. Understanding binary arithmetic essential for working with binary numbers and performing calculations in binary representations. Next is the American Standard Code for Information Intelligence, or ASCI. It is widely used binary code that represents characters in the English language. It is assigned unique 7-bit binary patterns to 128 characters, including uppercase and lowercase letters, numbers, punctuation marks, and control characters. It was also developed in the early 1960s to facilitate the exchange of information between different computer systems and devices. ASCI is the foundation of the character encoding in computer systems and communication protocol. So this is the ASCI as a binary character table. So there's a code for uppercase and lowercase. So the example for that is we need to decode this example. So we need to decode this. So 1 0. So 1 0 1 1 0 0 1 0. So here we need to find the letter. Match, so it is equal to match. Next is 1 0 0 0 0 1 is to uppercase letter A. Just need to find code is represent. So ASC code remains relevant in many applications, including text processing, file encoding, network communication, programming. While newer encoding standards like Unicode have expanded character support, ASCI codes continue to represent reversing English text and providing compatibility with mistake systems and software. That's all for my report. Thank you.